आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start the question. Question says that using Gauss law obtained the expression for the electric field due to the uniformly charged thin spherical shell of radius r at a point outside the shell. Draw a graph showing the variation of electric field with r for r greater than r, okay, and less than r. So if we talk about the spherical shell, okay, let's say this is the spherical shell and it has the radius r, okay, so it has the radius r and we have to find out outside the point, okay. So let's say, so let's draw a Gaussian surface, okay, and we have to find out the electric field at point P, okay, which is a distance of small r, okay. Let's say here we have to find out at point P and the distance is small r, okay. So we draw a Gaussian surface, okay. So if we assume this surface only for now, the electric field, the direction of electric field will be perpendicular to the surface, okay, electric field, and the direction of area vector, okay, surface vector, it is also perpendicular to the surface, okay, like this. So here we see that the angle, let's say theta is 0 degree between the surface, that is area vector, and the electric field, okay. So theta is 0 here, okay. So if we apply the Gauss law, we can write the flux equal to the surface integration of E dot ds, okay, and this is equal to the q enclosed divided by the epsilon naught, okay. So here we can write surface integration of E dot, here area we have taken is A, so A cos theta, this is the angle between the electric field and the area, okay, and this is equal to q inside divided by epsilon naught. Now the theta is 0, so we can write theta is 0, so we can write E dot dA equal to q inside by epsilon naught, okay. Here we can write E, okay, integration of dA equal to q inside by epsilon naught, okay, and if we integrate the area, okay, this will be, as this is the spherical shell, so this will be pi r square, okay. So here we are considering the r which is at a distance, okay, small r, okay. Here we are calculating around this point, so this is the radius, that is small r. So here we can write E into 4 pi small r square q inside by epsilon naught, okay. So we can write the electric field equal to 1 by 4 pi r square q inside by epsilon naught, okay. So this is for the small r, okay. So if we write the electric field for the capital R for this shell, we can write 1 by 4 pi r square q inside by epsilon naught. Okay, so here the charge on the surface, okay, is the charge on the shell. Okay, so this is the value of electric field. Now if here we see that if we put r equal to small r, okay, we can get this equation. Okay, but if we try to find out the electric field inside the shell, that is r is less than the capital R. Okay, so what will happen here? So if we try to find out inside the cells, let's say somewhere here, okay, let's say this is P dash, so the charge is on the surface, there is no charge inside the spherical shell, so electric field will be 0, okay, if r is less than r. Okay, so now if we try to plot the graph, it will be like this. Okay, here it is electric field and here the distance from the center. Okay, so here we see that till we reach the capital R, the electric field is 0. Okay, so let's say this is the R. Okay, so till then the electric field will be 0. Okay, and then at point R, okay, at point R, when the R is equal to R, the electric field will be maximum. Okay, and then it will decrease like this as we proceed to the small r. Okay, so the distance greater than the capital R, the electric field will decrease. Okay, and the electric field will be directly proportional to 1 by r square. Okay, so the curve will be parabolic. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।